Welcome to this video on the topic of advanced trigonometry. In this video, we're going to have a look at how we can solve equations that involve the trig functions. Now, looking at example 1 here, we have 2 sine x divided by root 2, and it's all equal to 1. The first step in solving this sort of problem here is we need to make sine x the subject of the equation. Now, doing that, the first step is we have to multiply both sides of the equation by root 2. That will yield 2 sine x equals root 2. Next step is we need to eliminate this 2 on the left hand side. Dividing both sides by 2, we get sine x is equal to root 2 over 2. Now, here's where we do something a little bit strange. Rather than just taking the inverse sine function of both sides of the function, or both sides of the equation, we're going to write something. We're going to say first potential solution. So this is the first potential solution to this problem. We go x equals inverse sine of root 2 over 2. And if you're well versed in your trig functions or your trig exact values, you're going to identify that this is going to be 45 degrees. Now at this point here, you might be tempted to declare victory over the question. However, the problem lies in that we're expecting at least more than one solution for this particular equation here. Reason being is that if we refer back to our unit circle and we have a think about where do we expect the inverse sine of root 2 on 2 to lie on the circle, well, what we find is that this is a positive value. And therefore, we need to look for where the sine function is positive on the unit circle. So we can go all stations to central. And therefore, we're expecting positive solutions in the first and the second quadrant. And thus, we're expecting answers in both the first and the second quadrant. Now, because of that, we have to look at the identities. So the angle represented in the first quadrant is simply theta. However, the angle of interest in the second quadrant is going to be 180 degrees minus theta. For the third quadrant, it is 180 degrees plus theta. And then finally, for the fourth quadrant, it's 360 degrees minus theta. Not that we need these last two. But what we're interested in is our answers are going to come from here, here, and here. So, going forward, the value of x, given that we're working in the first quadrant, is going to be 45 degrees, and we're going to call that our first solution. Now, going for the second solution, which lies in our second quadrant, we're going to go x is equal to, and then we're going to go 180 degrees, take the 45 degrees that we had up here. Reason being is that if we have a triangle over here which represents our theta, we're expecting a mirror image triangle over here representing our other theta. And therefore, the value of x for our second solution is going to be 135 degrees. And we say that's our second solution. Thus, in conclusion, the values of x that satisfy the equation are going to be 45 degrees and 135 degrees respectively. So this is our first quadrant solution and this is our second quadrant solution. So at face value, it seems like a pretty simple problem, but at an in-depth perspective, what we find is that the solution is not so trivial after all. Now going on to example 2, we have minus 2 cosine x. All divided by root 2 is equal to 1. Once again, we're going to solve this problem by rearranging such that cosine x becomes the subject. Thus, we find that cosine x is equal to the negative root 2 over 2. So, our next step is we need to consider the first potential solutions. So, first potential. Now, in the first example here, the potential solution we got indeed turned out to be the first solution to the problem. However, what we're going to find with this problem here is that our potential solution isn't actually a solution to the problem. What we're going to do to find the potential solution is we're going to go x is equal to the inverse cosine of root 2 over 2. So what we're going to do is ignore the negative. The reason for this is that because we're looking at a negative solution over here, what we're going to find is that if we type that in our calculator, the solution that our calculator will give us will be outside the first quadrant. And the problem with that is that if we're getting the solution outside of our first quadrant, we don't actually know which quadrant it's going to be working in. However, if we force the inverse cosine of this positive value over here, we're always going to get the equivalent angle inside the first quadrant of the unit circle. So the first solution that we're going to get is somewhere over here, and it's going to come out to be 45 degrees like so. However, the location that we're expecting our solutions are going to be where cosine is negative. So if we go all stations to central, we are expecting solutions here and not there, here and here. So in the first and the second quadrants. So this is where cosine is going to be negative. Consequently, we have to refer back to the equivalent angles in the other three quadrants. So the first quadrant we're getting theta. So our theta responds to this value we got over here. So this would be 45 degrees. Now the thetas that we're looking for are the 180 minus theta and 180 plus theta. So computing these, what we're going to find is that x is equal to 180 degrees minus 45 degrees, and that will yield a value of 135 degrees. And then secondly, we're going to get 180 plus 45, which will yield a value of 125 degrees. So this is our first solution, and this is our second solution. Putting it all together, we therefore find that the values of x are 135 degrees and 225 degrees. Now, evaluating this on our calculator to check that we've done everything correctly, we can say up we come, then we'll go to run matrix. So I click 1, I'll clear all the memory because I don't know what's in there, and I'm going to make sure my calculator's in degrees. So change that from rad to deg. Now I'm going to press exit a few times and I go option, calc, solve n. Reason I'm choosing solve n over solve is that I'm expecting multiple solutions. So solve n, then I'm going to type in the initial equation. So we're going to go minus 2 cosine of x. I'm going to include my brackets or else I'll get strange results from the calculator. Then I'm going to go shift square root of 2. That is all equal to 1. Putting in a comma and telling the calculator solve for x. I close it all up and I hit execute. The calculator will give me a warning saying that there are more solutions. Then I tell it exit, and it's going to give me all of this mumbo jumbo. But not to worry, what we're going to do is we're going to swing across, and solutions that we're interested in are 135 and 225. So in summary, what we learnt in this video was how we can solve equations that contain the trigonometric functions.